As a 3D artist, you have a few ways of doing 3D modeling, like using polygonal modeling, box modeling, and so on. But one of the ways is called NURBS. The question is, why is it not popular anymore? Today, NURBS, I would say, feel a bit like the old feature in 3D software that is still there, but you can tell it is no longer the main focus. I mean, if you open 3D modeling software like Blender, Maya, or even Max, you can use NURBS, no problem, because it is technically supported across all of them. But everything around it clearly pushes towards polygons, sculpting, and procedural tools instead. In practice, what's happening is that developers haven't really invested much into evolving NURBS workflows. In Blender, for example, the modeling toolset has massively expanded, with things like geometry nodes, sculpting, and modifiers, while NURBS stayed almost untouched for years. Even within the community, people openly treat it as something that hasn't kept up with the modern workflows, more like legacy tech than something actively being pushed forward. And this tells you a bit about priorities. The same can be said about 3ds Max. It has great modeling capabilities using NURBS that hasn't been updated in years, as far as I know. And it is not because NURBS became useless, it is just that the other methods became way more convenient, even in fields for which NURBS were created in the first place, like aerospace design, automotive, and ship design. Polygonal modeling plus subdivision can already give you smooth results, but with way more flexibility. You can sculpt, do retopology, animate, and send assets straight into game engines without any extra conversion. NURBS, on the other hand, still feels tied to a more technical, curve-based workflow that doesn't fit how most artists work today. So what you end up with is this weird situation. NURBS are still built into most major 3D software, still mathematically powerful, still important in certain niches, but for the majority of 3D artists, it is basically sitting on the sidelines. Now, if you want to go into the details, I can talk about the main reasons modern 3D work doesn't focus on NURBS anymore, and honestly it is just about the industry changing priorities. You see, back in the day, the goal was how do we smooth surfaces, and NURBS solved that perfectly. But today, the goal is more like how do we work fast, iterate quickly, and get this into a game engine or rendering pipeline without any headaches. And NURBS just doesn't fit that mindset really well. So to be honest, a big part of it comes down to flexibility. Polygonal modeling is basically like digital clay compared to using NURBS. You can push, pull, sculpt, break things, redo them, and nothing really fights you. NURBS, on the other hand, is more structured and smooth. This is great for precision, but when you're trying to design a creature, a character, or even a messy asset, it starts to feel restrictive. Even small changes can require adjusting multiple control points, which slows things down compared to just grabbing vertices and moving them around. Another huge reason is real-time workflows. Everything today is built around engines like Unreal or Unity, and those engines run on polygonal meshes. So NURBS cannot be used directly, so you always have to convert it into polygons anyways. At that point, most artists just think, why not start with polygons from the beginning? And this extra conversion step just doesn't make sense in fast production pipelines. There is also the rise of sculpting and procedural workflows, which completely changed how people build 3D assets. Tools like sculpting brushes or node systems let you create instantly complex shapes in very intuitive ways. And using NURBS doesn't play well with that kind of workflow because it is not designed for organic and irregular forms, as I said. It shines with clean, controlled surfaces, but struggled with the kind of messy detail that modern projects demand. Now let's go back in time and take a deeper look. Back in the early days of 3D, NURBS weren't just a tool. It was actually one of the main ways people built 3D models. If you look at the 90s era, especially in VFX, NURBS were actually everywhere. Tools coming from companies like Alias, which later became part of Autodesk Maya, were heavily built around NURBS modeling, and that tech became the gold standard for film production at the time. Some of the biggest early CGI projects and studios relied on it because it allowed them to create smooth and high-quality surfaces, without needing insane amounts of geometry, which computers back then simply couldn't handle. What's even crazier is that NURBS weren't just used for props or vehicles, it was used for much more than that. In early 3D graphics, 3D artists even built organic surfaces and characters using NURBS. It actually sounds weird today, because we associate characters with sculpting and polygons, but back then, this was just how things were done. The tools and hardware were limited, so NURBS offered a practical way to get clean results without heavy computation. Another reason is that it was important that polygons weren't as advanced as they are now. They couldn't easily produce smooth surfaces, and subdivision modeling wasn't really mature yet. So if you wanted something that looked polished and curved, like a face or a creature, or even a car, NURBS were often better options. It wasn't just an alternative, it was sometimes the best available solution at the time. Now, if you are still here, I want to talk about the origins of NURBS. I mean, where they actually come from. If you really want to know where they came from, the origins of NURBS in 3D modeling actually go way back before computers, starting from a very physical, hands-on problem: how to draw smooth curves. In shipbuilding and aircraft design, engineers used flexible wooden strips, called splines, bending them through fixed points to naturally form smooth shapes. This idea of controlling a curve through a set of points became the foundation for everything that came later, eventually turning into a mathematical concept once computers entered the picture. In the late 1950s and 60s, as industries like automotive and aerospace started adopting computers, engineers needed a way to describe complex curved surfaces mathematically, instead of relying on physical models, and this led to the development of Bezier curves by Pierre Bezier and algorithms by Paul de Castillo, both working independently in France. Their work introduced the idea of shaping curves using control points, which made it possible to design smooth car bodies and industrial forms digitally rather than by hand. As designs became more complex, Bezier curves alone weren't enough, so researchers expanded them into B-splines during the 60s and the 70s. These allowed for better control over large, complex shapes, because adjusting one part of the curve wouldn't distort the entire form. You see, this step was crucial, because it made the curve-based modeling practical for real engineering problems, and laid the groundwork for more advanced systems, if you know what I mean. The real breakthrough came in the 1970s, when the engineers introduced weights into B-splines, creating what we know as NURBS, or non-uniform rational B-splines. This allowed them to represent not just freeform shapes, but also exact geometric forms like circles and cylinders, something earlier methods couldn't do properly. Around 1979, researcher Ken Forsprey formed this approach, and it quickly became usable in real software. From there, NURBS spread rapidly into industries like aerospace and automotive, where precision was critical. Companies like Boeing adapted it for designing aircraft surfaces, because it allowed a single mathematical model to be used consistently from design to manufacturing. And by the 1980s and 90s, NURBS had become the standard in CAD systems, and eventually made its way into early 3D software, like Max, Blender, and so on. And there you have it, guys. If you like this video, please give it a thumbs up. Also, please subscribe to the channel to receive more videos like this. Thank you very much for watching, and I will see you in the next one.